everyone. Welcome to another great section of this tutorial class. Today we are going to be looking at another great or sweet topic in physics, which is vectors. Yes, I know you guys have heard about vectors. Maybe some of you are thinking, what is this vectors actually about? Today, I'm going to show you guys what this topic is all about. The meaning of vectors, quantities that we call vectors, and so on. How to run algebra, so vectors, vector algebra, and the rest. And how to add vector quantities, that is, rules of vector additions. So please ensure you don't distract yourself by any means, and ensure you have subscribed to this channel. To subscribe is free. Just to click on that solution icon. That is all. You're not going to use any money for it. Please ensure you do so, and you'll be blessed to do that. And please listen. We'll be doing how to know vector quantities, and we'll also be doing something like what we call rules of vector addition, which is we're going to look at the paragonal law of vectors addition. We're going to look at the resolution of vectors. How to resolve vectors into planes using the Cartesian coordinates. So please ensure you watch this video from beginning to the end. Don't skip any part of the video in order to get the full details of everything I'm going to be explaining in this wonderful video. So let's go over to today's vectors. Now, we take down physical quantities. Remember we said all measurable quantities in physics are called physical quantities. Any quantity at all that we can measure in physics, we call such quantities a physical quantity. Now, physical quantities now can also be classified in terms of their magnitude and direction. We can also what? Classify physical quantities or represent physical quantities in terms of magnitude and what? And direction. Physical quantities also be classified in terms of magnitude and direction as number one, the scalar quantities, and number two, the vector quantities. Like if you want to classify physical quantities, or you want to something like give physical quantities in terms of magnitude and direction, we have them as number one, scalar quantities. Then number two, also have them as vector quantities. Some will be called scalar, while others will be called vector. So that we're having fundamental and derived. Now, some fundamental quantities can be scalar, they can be vector. Some derived quantities can be scalar, they can also be vectors. What is a vector quantity? Which of the physical quantities do we call a vector quantity? A vector quantity is a type of quantity that has magnitude and direction. Vector quantity is a quantity that has magnitude and direction and also obeys the paragonal law of vector addition. Also obeys the paragonal law of vector addition. Example of these quantities can be displacement, velocity, force, moment, electric field, and so on. It has magnitude, it has direction, it also obeys the law of paragonal law of vector addition. Why the scalar quantities are quantities that has just magnitude but no direction. It has just magnitude but no direction. Scalar quantity has magnitude but they don't have direction. The example can be mass, we have speed, distance, etc. and so on. We have a lot of them. And a vector, let's see going. A vector is always represented with a straight line, the line with an arrowhead. A vector is represented what? A straight line and what? An arrowhead. So if you want to represent a vector, represent with a line, very straight line, then the thing will have an arrowhead. The thing should be uniform. Then you also have an arrowhead in which the length of the line will denote the magnitude of the vector, while the arrowhead will denote the direction of the vector. So if I label this place A and I label this place B, So if I want to call this vector, I will say this is vector AB. This is vector AB. That's how I'm going to declare it. It's not vector BA because BA and AB in terms of vectors are not the same. Take note of that one. Very, very important. So this one is vector AB. Why? Because it's moving from A to B because of this arrowhead. So if I turn this arrowhead this way, let's say we turn this B, now turn the arrowhead this way, let's say this is B, this is A. So if I want to call this one vector BA, vector BA. That's how I'm going to call this one vector BA. Because it's moving from B to A. So we take note of the length and also the arrowhead and the direction. So that's something like vectors. I also have one-dimensional vector, two-dimensional vectors, and three-dimensional vectors. Or vector in one dimension, vector in two dimension, and vectors in three dimension. So vector in one dimension can just be the form of a straight line vector. Let's say it's moving the x-axis now. So I'm going to relate this vector in the x-axis, and we also call this axis I. Take note of that. Like x-axis, we also call it I. Then this is just in one dimension. What about two dimension? It's moving in plane. Let's say it's moving in plane. Just the Cartesian plane x and y. Then let's call this place J, and this side is I. Remember that? This one is J, y, the s is I. So this one is AY, this one is AX. So this is the vector in two dimensions. So we in two dimensions, and it's having two of these. We call this all this sign you are seeing here, I, all this stuff you are seeing. We call them unit vector. We'll look at that later. Class go on. So let's look at three. This is two dimension, this is one dimension. Look at three dimension now. Three dimension. We're going to take a shape like this. We're going to have something like this. So this is going to take our y, x, and this take the z direction. The z direction. So because AZ, AX, and AY. So this is the J, this is the R, while this is the K direction. So all this I, J, K you are seeing there, I, J, and K you are seeing there, we call them unit vectors. We only use them, mostly use them to give directions to physical quantities. So any vector go to the R means go to the X, go to the J means go to the Y, go to the K means go to the Z direction. So please think of that, it's very important. So also our types of vectors we have unit vectors, that's what we are seeing here. Unit vectors is the vector's magnitude is unit. The vector whose magnitude is unit is called unit vector. We also have the position vector, vectors already specified. Then we also have zero vectors, or no vectors. Zero vectors, they have zero magnitude or they have their initial and terminal point coincide. Zero vector is a vector whose initial and terminal point coincide. It meets at the same place, so it tends to be zero. So please take note of that, it's very, very important. So now how do we operate all this? For example, if I have something like this, I think we have A. Vector A will be equal to 4I. That means this is a vector, this is vector A, and the magnitude is 4 in relation to the I axis. And which one is I axis again? Please, are you following me? The I axis, remember, is X. Check. The X is I, the Y is J, the Z is K. Think of that, it's very, very important. So this vector A going to the S direction, having a magnitude of what? Of 4. So let's run through vector algebra to see how to run vector algebra. So let's take the question. Question 1. If vector A is equal to 2I plus 3J, and vector B is equal to 4I minus K minus 2J, find let's say I, number 1, vector A plus vector B, and number 2, vector A minus 2B. So let's do this and this. So we have to run this vector algebra. Now, if you want to run this vector algebra, what you do, you add vectors with same unit vectors only. They all have the same, remember we have the I, J, K. So you add I to I, add K to K, add J to J. Ensure you don't add vectors that don't have the same unit vectors together. So you add the magnitude of vectors there, only the magnitude that have the same unit vector. For example, let's say for the question we have A plus vector B will be, what is vector A? 2I plus 3G. What is vector B? Or 4I minus 2G. So if I ask what is A plus B transition, I'm going to have vector A plus vector B. That will be equal to, first you put the bracket, plus 3G, then plus 4I minus 2G. Next thing, add vectors have the same, just add like terms together. Those that have the same unit vector together. So we will have 2I plus 4G plus 3G. Okay, 2I plus 4I, sorry about that, plus 3G minus 2G. So that's what we will have. So we add those that have this I will be I and G equal to G. I hope you are following that. So the next thing I will have will be equal to 2I plus 4I, so that's going to give us 6I. Then 3I minus 3G minus 2G, that will give us plus 1G. So 2 minus 2 gives us 1. So we have 6I plus G. If it's 1, we have to just put the G there and silent 1. It won't be latent, it won't be shown. That's how we do present our scores in mathematics. We have 1G. 1G is empty as G. Take care of that. Then number 2. How we got this? Let's say A plus B. Our A is this. That's A, this plus this. Add this to this, add this to this. That's all. Just this plus this plus this. We have this. 6, that's 4 plus 2, we have 6. 3 plus minus 2, that's 3 minus 2, what's that one? 1. That's all. So let's look at this other one, which is our A, vector A minus 2 vector B. So what is that going to give us? We will have vector A. Vector A is 2I plus 3G, that is 2I plus 3G. 2I plus 3G. Then minus 2 vector B. What is vector B? 4I minus 2G. 4I minus 2G. So this will give us 2I, so opening bracket 3G, minus 2 times 4, that gives us minus 8. I. Minus times minus gives us plus. Then 2 times 2 gives us 4 G. So we're going to have 2 times 2 gives us minus 8I. Then minus times minus gives us 4. That's plus. 2 times 2 gives us 4. Then we have G. Next, add this to this, add this to this. So we will have 2I minus 8I plus 3G plus 4G. So 2 minus 8, that gives us minus 6I. 3 plus 4, that gives us plus 7G. Answer. This is what we will have. This is how we run vector algebra. So let's look at another one, another sweet question. Let's see question 2 now. If vector A equals to, let's say, I plus J plus 2K. I plus J plus 2K. And vector B is equals to, let's say, you have 6I minus 2G plus K. Find, let's say, find A, that is 2A plus 3B. Find 2A plus 3B. What will be value for 2A plus 3B. So let's do that. See what I got. Look at the value for 2A plus 3B. So we will have answer will be 2A, that is 2 times. What is A? I plus J plus 2K plus 3B. 3B. What is B? What is B? 6I minus 2G plus K. That's 3B. So next, if you put it back, we're going to have 2 times I equals 2I, times J gives us 2J, 2 times K, that is 2 times 2K, 2 times 2 gives us 4, and we have K, plus 3 times 6 gives us 18, 18R, then plus times minus gives us minus, 3 times 2 gives us 6G, then 3 times plus K gives us plus 3K. So we are going to have plus 3K. The next thing, add I to I, J to J, K to K. That's how it's done. Add I to I, J to G, K to K. So we're going to have in this way. That is 2I plus 18I. And for J we have 2J minus 6J. And for K we have plus 4K plus 3K. That's what we'll be having. At the end of the day, we'll be having this plus this, that is 20R. Then 2 minus 6 minus 4J. 4 plus 3 is plus 7. This is what we're having as our answer. That's what we're having as our answer. So please ensure you are following. Ensure you are following. So you do this one now. Let me see if you can get the answer. Like just a short classwork, not short classwork. A short classwork. A short classwork. Let's see we have just from the question 2 we look from this question out. From this question 2. From question 2. From question 2. From question 2. You remember that, okay, from question 2. We were told that A is equals to I plus J plus 2K. The vector B is equals to 6I minus 2J plus K. So class what we are going to find A minus B. Find vector A minus B. What will be vector A minus B? Let me see if you can do that. And also, let's see this one is 1. Then 2. Also find vector A plus B. So find vector A plus B. Let me see what you are going to have. So if you do this and this very well, the answer will be, okay, this will be the answer. Our A minus B will be this. Our A plus B will be this. So what you have to do now, you have to try it, ensure you solve it, to see if you can get the answer. It's very, very important. Very, very important. Thank you.